recording. And here we go. Okay, so moving right along, our balanced science instruction document can be found on our Cobb County website. This document gives an overview of how we expect you to teach science in Cobb, and our 2022 Science Department priorities are listed right here. And today we're going to be focusing on teachers will move instruction from one dimension to 3 dimensions. And that's just a fancy way of saying we're going to use the 3-dimensional science workshop model approach to engage our students with science instruction. So today I'm going to be talking about different reading strategies that you can use in different parts of the science workshop model. So what is the science workshop model? It's a new framework that the science department is pushing out, and it's to help all of our teachers that complain that they don't have enough time to teach science during the day. We know that the literacy and math block do take up the majority of the day, and that your content area might only get 15, 20, 25, 30 minutes. So we have devised a way to make sure that you get to science on a daily basis, and that is through science workshop model. So you have an opening, a work session, and a closing. 10-minute opening where you introduce a phenomenon, and then the students are actively involved in the science and engineering practices during the work session. Just to give you kind of an overview of what science workshop model is, here you can see an infographic that we have developed for you teachers in order to help you understand the science workshop model and what it looks like during each segment. So the opening, like I said, is where you introduce your phenomenon and you have students coming up with questions about that phenomenon, and you're going to model work session expectations. The biggest difference between traditional science instruction and science workshop model instruction is that the students are going to be actively involved exploring with the science and engineering practices during the work session time. And that's done through centers or workstations, science centers or workstations. So you'll have 4 to 5 science stations that you can utilize for an entire week, and students will work through those stations. And then you're going to bring students back together for a student-led discussion where they can demonstrate the mastery of standards and show their thinking. What does science workshop model look like? Well, this is some ideas on the bottom of what each segment can look like. You can introduce your phenomenon with a video clip and a read aloud. That's what we're going to be looking at today, some reading strategies. Then your students are going to create guiding question boards, whole group, and then they're going to move into their small group or independent stations or centers. And those are just some suggestions on stations that you can utilize. And then for the whole group discussion, this gives some examples of how to conduct that and what that looks like, and also some formative assessment ideas. Just as a reminder, science workshop model units are available for each K-5 science unit in CTLS Teach. To get there, you'll go into your grade level science course, click on Unit Navigator, select a unit, click on Topic Navigator, and then you're going to scroll down to Instructional Strategies, and here's where you'll find the science workshop model units. Those units are 2 weeks long, with an additional third week for our 3rd through 5th grade units, with the embedded STEM and performance task challenge. So let's get into how we can utilize some reading strategies during the science workshop model. So why is reading in science important? Well, of course, literacy. Literacy in science helps to develop students' curiosity about the world around them. And that's what science is, understanding the world around you. And we're going to use that curiosity to help them engage in these different reading strategies. Science reading allows students to question their knowledge, their skills, their values, even their attitudes around the world around them. And we know that we use more than just the textbook in science. We want to introduce a wide variety of science-based reading related to the content, whether it's science trade books from NSTA or passages that you find off of Newsella or ReadWorks. We want to introduce a wide variety of science reading for our students. So today we're going to be looking at 4 different aspects of science literacy: developing vocabulary, using and building prior knowledge, predicting and inferring, and think-alouds and comprehension. And what I'm going to share with you are some strategies that you can use for each four of these different aspects. And I'm going to give you some grade level student work examples as well, along with showing you the graphic organizers that you can use with this. And I'm going to give you examples of books that you can use this with. So let's start off with developing vocabulary. The name of this strategy is called Concept Definition Map, and it's just a graphic organizer that you can use to help your students clarify the definition of those important science content vocabulary terms. This graphic organizer is really allowing the students or empowering them to learn more than just the key term and the dictionary definition. They're really having to demonstrate their understanding by relating it to analogies and illustrations. So prior to assigning a reading selection, you're going to choose a word that's key to comprehending the informational science text. You're going to write that term on the board in that center of the concept of definition activity sheet that you can see right there. That middle box says concept. You're going to then guide students in adding to the activity sheet by asking them the following questions. What is it? What are some things you know about it? What is it like? And what is an example of? All right. So then students are going to read the text and add information as they read. Okay. So here's some student examples. Okay. So let's think about this. We are introducing a new unit to our students, okay? A new science workshop model unit. And we're going to do that by choosing a read aloud. Look at this grade 1 and 2 example. The teacher can read the book Planting a Rainbow by Lois Ehlert. You can write the word plant in the concept box. And then these are just some examples of what students have done in order to develop their own definition of that word. So here you see something that grows in the dirt needs sun and water to grow. What is it like? So they're making an analogy, a related analogy. So that's pushing their cognitive critical thinking skills to the next level. A child, because it needs food, water, and care so that it will grow. Absolutely. And then you see there are 3 illustrations and examples at the bottom. Here's a grade 3 through 5 example. The concept is an invertebrate. The teacher can introduce the topic by reading a couple of pages from this informational book on invertebrates. The Smithsonian Little Explorer books are fabulous. And then here the teacher is asking questions. And then after they read the passage and as she read the text, students are adding to their examples and illustrations. What about our students that need a little help? So this would be a great activity for you to do or a strategy to use during work session time. During Science Workshop Model work session time, you have your students working independently or in small groups on a station. This could be a vocabulary station on its own if you have 3rd or 5th graders that you feel comfortable enough to do it independently on their own, or this can be a teacher-pulled group as well, just so you can model it and scaffold it to begin with. So what about differentiation ideas? ELLs, when you're using the concept of definition graphic organizer, allow them to work with a partner. Below level reading students, teachers can fill out a section. So not only could they write the word, they could do the analogy part, maybe put 1 or 2 illustrations. And then above level students you can allow them to do further research by looking at various definitions from different resources and having them produce something, a product of some sort, maybe a poster, explaining the word in a little more detail and creating their own definition. All right, let's look at another strategy. Now we're going to move on to using and building prior knowledge. This strategy is called a think sheet, and I'm going to explain it to you first, but I want you to keep in the back of your mind what this reminds you of, because I know we've seen this in various forms throughout the years. So this is called a think sheet. So the best way to build on prior knowledge is creating those shared learning experiences for our students. And science instruction time is the best way to do that. All right, so we're asking our students to examine their own background knowledge and questions on science content before they actually read. And what this does is it helps new science information remain in the long-term memory because we're making connections. So think about this. The new science unit is for first graders on chicks. The teacher can hold a class discussion in which students answer questions, right? The teacher might record those shared ideas on the board as the brainstorming activity to activate students' knowledge about baby chicks. Some students may have little prior knowledge about chicks, while others might have been to a farm or lived on a farm or know someone that has watched chicks hatch from eggs. Regardless of the knowledge of students, creating shared learning experiences in which background information is activated provides all students with enough information to effectively read about those concepts. So, how do we utilize the Think Sheet? So, before reading a science text to students, you need to determine the main idea of the passage, okay? So everyone's going to get a think sheet, and you're going to present the main issue to the class and ask students to generate questions that they have about the topic. You're going to ask them to explain what they hope to learn from reading, and you're going to write their questions down in the first column if you're doing this as a class think sheet, or you can have your students write it down on their own. Next, you're going to ask students to explain what they already know about the issue and encourage them to share, even if they're not sure if the information is correct, because we're going to actually do the reading and put some text support down. So you're going to write the information, their thoughts, and their thinking in the second column. So then you're going to need to explain to students that our purpose for reading is to answer the questions that they've come up with or that you've come up with together as a class. And you're going to locate the answers to their question and determine if their thoughts were supported or completely wrong about the issue. And so as they read, they record the important ideas from the text in the last column, the text support and evidence column. And we're going to have your students share what they've learned after you've done the reading and after they've had time to write down their text evidence. Does this remind you guys of anything a little bit? It completely reminds me of a guiding question board, and that's something that we do after we introduce a phenomenon to our students. Very similar to a KWL. This just has another name, and it's just set up a little bit differently. But let's look at some examples of a think sheet. And as you can see, this is only, the think sheet I showed you a while ago has tons of rows, and this is developmentally appropriate. We might not want our kids to fill out every single row. They might not be able to on the graphic organizer. So if you look at this first and second grade example, the issue is the life cycle of chicks. This is a great book that you could introduce this phenomenon with. But here you have your questions. How long do the eggs take to open? How long does it take a chick to peck out of an egg? How fast do the chicks grow? And then you have your student thoughts. And then after reading the book, your students have the text evidence that they need. And even in the last one, how fast do chicks grow? It wasn't in the reading. And that's okay. They might not figure out the answer to every single question. But the discourse, the discussion, the comprehension from the text, that's all going to be locked into their long-term memory as they make connections to the topic. Here's another example, a 3rd through 5th grade, plants and carbon dioxide. Now, I couldn't find a book that I had on this topic, but I found a really cool infographic that kind of explained it for our students that you could utilize in your science classroom and have them ask questions about it and put their thoughts down on their think sheet. And then you would have to find a passage about plants and carbon dioxide or lift from a text from the HMH textbook or another resource you have in order for them to find that text support and evidence. So when could I utilize this strategy during science workshop model time? This would be great during the opening with a phenomenon. Now, your phenomenon can be an image, it can be a read aloud, it can be a text list. any way that you're introducing some science content to students that's going to make them question something. So how can I use this and differentiate it? With your ELLs, you're going to have to model how to formulate questions, and you can do that by guiding them and scaffolding. Below level students, scaffolding with some responses and allowing them paired reading or listening aloud. And above level, always allowing them to conduct further reading and research to find answers to any of the questions left unanswered. That would be a great extension project. All right, so that is the think sheet for prior knowledge. Next up, predicting and inferring. This is called picture prediction, and it's actually one of my favorite strategies that I have found. This strategy allows students to closely examine and integrate information from a lot of different resources, mainly pictures, presented in different media and formats in a science text prior to reading. All right, so this is definitely prior to reading, and it's helping them predict how the pictures are related to one another. And they're going to generate a list of words and concepts associated with those pictures. And the research behind this strategy is that students are more motivated to read when they have determined the purpose of a reading task. So here's what I'd like you to do. I would like you to get a sticky or a scratch piece of paper, and we're going to do this one together. So on my next slide, I have 3 pictures. And when I show you the 3 pictures, I want you to generate a list of words and concepts associated with the pictures. All right, here we go. I want you to look at these 3 pictures, 3 images. You're going to write down any words that you think of when you look at the pictures. Think about what you'll be reading about and write down what you think the reading will be about. That is the funniest sentence I think I've ever written. All right, anyone want to unmute and tell me what you think we are going to be reading about?
Erosion?
Yes, good, Kelly. We are going to be learning about erosion, weathering and erosion, and deposition. Absolutely. And then I would go on to read a text lift or an actual read aloud with my students, or they could do this in a station, in a work session station. You can have images in a baggie already, and the students will have to put those in the boxes on their half-page graphic organizer, and then they can write down those list of words and concepts associated with those pictures. Then they will go to actually read the passage or the science text. Here's some examples. Here's a picture prediction for 1st and 2nd grade. The teacher has drawn 3 pictures on the board, and the students have copied those photos down as well. They're sketching it out to the best of their ability, and the words they came up with was blowing, bubbles, soda, helium, and floating. And the prediction is the pictures are about air inside of things and how the air moves. Looking at the 3rd through 5th grade example, the students have done a great job at looking at those different photos and figuring out exactly predicting what the reading will be about. So this would be a great strategy to use during a work session station, either a small group station where students are working with a partner to read, or independently. Some differentiation ideas for your ELL students is giving a word bank or a pre-made list of words, maybe with some photos as well. Below level students work best in a small group setting with this strategy, and above level you can give them a different set of images to challenge their thinking, or even more. And then another extension would be having them come up with some images for the topic as well. Okay. Last but not least, we have our think aloud and comprehension strategy. And this is called look for important information, think aloud. Okay, so basically for comprehension, we know that expert readers know how to pay greater attention to important sentences and they ignore the minor details. This strategy assists students in learning how to locate the most important information in a science reading after it's modeled by the teacher. That's the most important part. The teacher is going to demonstrate for the students the thought process behind identifying this information in science reading. So I'm going to show you an example. Here we have a first and second grade example and a third through fifth example. But looking at the first through second grade example, the teacher would say this. At the beginning of a reading selection, the author usually tells you how to find the most important information. The author is going to say certain words more than once. Sometimes the author also says the same thing more than once. Sometimes the author will give examples. If you can find the author's big idea, then you can find the most important information faster. Notice how the most important thing to learn is right here, and describe how you know it's important. So I am going to stop sharing for a second and model this for you. So I have this amazing book, The Next Time You See a Spider. If I was utilizing this with my students, I would say that whole little spiel about the author usually puts the most important idea in the first sentence, and all the sentences after that are the supporting details. But we need to pay close attention to what the author says at the beginning so we know what he really wants us to know. So here, perhaps the most well-known type of spider web is the orb web. These beautiful and elaborate webs look like the wheel of a bicycle, with threads connecting each spoke. When an insect flies into the web, it becomes trapped in sticky silk. The spider, usually waiting in the center of the web or hiding nearby, feels the vibration on the threads and rushes in to get its prey. I can see that the author has told us in the first sentence that the most well-known type of spider web is the orb web. And they've even put it in italics so we know that this information is the most important in the paragraph. So that's an example of how you can utilize the look for important information, think aloud with your students. This would be a great strategy to use. I'm going to share one more time. This would be a great strategy to use during the work session time if you're doing a small group and you want to read a science trade book, or you can utilize this during the opening as well if you're going to integrate a read aloud to introduce your phenomenon. And we are running out of time, but just to recap exactly what we've gone over today, we have talked about integrating reading strategies for science during the science workshop model framework. And we looked at these 4 science literacy strategies: developing vocabulary, building on prior knowledge, predicting and inferring, and using the think alouds for comprehension. So all of these graphic organizers can be found in this amazing book, Reading Strategies for Science. It's a Shell education book. If you would like to borrow it, you are more than welcome to do so. It is the 2nd edition, and the author is Stephanie Masika, and she's done a lot of different reading books for science. And if you need help finding science text or science trade books, please let me know. Myself and the Title I Science Coach, Kelly, can help you in any way necessary. Any questions before we log off today? All right, no questions. Just a reminder, our K through 2 Science CCC meeting is Monday at 2:45 via Teams. I will send that link out to everyone. And the 3rd through 5th grade Science CCC meeting is on Tuesday at 2:45 on Teams. I hope everyone has a wonderful afternoon, and thanks for joining me today.
Hi, thanks.